So, here's a question for you. Ever wonder what actually keeps your lights on during a big storm? You might think of those massive power plants, or maybe the big transmission lines crisscrossing the country. But there's this hidden hero in our electrical grid, a device most people have never ever heard of. And it goes by a simple acronym, RMU. Today we're going to pull back the curtain on this unsung hero.
Okay, so let's just dive right in. The most obvious question, the one we're all thinking, is what on earth is an RMU?
You know, if you just punch RMU into a search engine, you're going to get a seriously confusing mix of results. Is it a remote monitoring unit, a medical university in Bangladesh, a maritime university in Ghana? I mean, it just goes to show you, context is everything.
But for the engineers and the technicians, the people who actually keep our power grid from falling apart, RMU means one thing and one thing only, a ring main unit. And trust me, it is absolutely critical for the reliable flow of electricity in our world today.
So here's the game plan for this explainer. We're going to break it all down. We'll start with a big problem it was designed to solve, then we'll see exactly how it works. Check out the main types you'll find out there, and finally, we'll take a peek into its future in the smart grid.
All right, so to really get why the ring main unit is so important, we first have to understand the fundamental problem it was built to fix, and that's the massive weakness of the old power networks. Okay, check this out. This slide shows you the huge before and after of grid design. Over on the left, that's the old way, a linear network. Think of it like a dead-end street. If a tree falls and blocks that road, well, everyone on that street is completely stuck. One fault, just one down power line, and a whole neighborhood goes dark. The solution? That's on the right, a ring network. This is so much smarter, it's more like a traffic roundabout. It creates a loop. So now if there's a problem in one section, power can just flow the other way around. It's robust, it's way more reliable, and it's basically the foundation of any modern grid.
But look, a smarter network like that needs a smart traffic cop, right? You can't just have electricity flowing wild. You need a device that can direct the flow, protect the whole system, and, act instantly when something goes wrong. And that is exactly the job of the RMU.
So, how does this electrical traffic cop actually work? Really, the best way to think about it is as that intelligent roundabout we just mentioned. It sits at these key intersections in the grid, managing the flow of power and making absolutely sure any disruption is contained.
So let's get the official definition down, just so we have it. A ring main unit is a compact, usually factory-sealed, piece of equipment called switchgear. Its main job, its whole reason for being, is to control, protect, and isolate parts of the grid. All to make sure that a fault in one tiny area doesn't cascade into a massive blackout.
And this is where the magic really happens. Let's walk through it. Imagine a tree branch hits a power line. Step 1. The RMU detects that electrical fault, instantly. Step 2, it acts like a super fast automatic switch, and it immediately disconnects only that one faulty section from the rest of the grid. And then step 3, power is seamlessly rerouted through the other side of a loop. For you and all your neighbors, the lights probably don't even flicker. It is that fast. And if you were to peek inside one of these unassuming metal boxes, you'd find a whole toolkit of heavy-duty electrical gear. You've got circuit breakers and switches. Those are the arms that physically open and close the connections. Fuses are there for backup protection. And then you have the protection relays, which are basically the brains of the operation. They're constantly monitoring everything, just waiting to give the command to isolate a fault.
Now, as you might guess, not all RMUs are built the same. They're mostly categorized by what they use on the inside to insulate all those high-voltage parts, to keep the electricity from jumping where it's not supposed to go.
This table gives us a really great side-by-side comparison. The most common type you're going to find is gas insulated, or GIS. It uses a special gas, often SF6, which lets the whole unit be incredibly compact and reliable, perfect for crowded cities where space is tight. Then you've got air insulated, or AIS. These use, just plain air. That makes them bigger and cheaper, which is a great fit for rural areas where you have plenty of space. And finally, we have solid insulated RMUs. These use materials like epoxy resin. They're kind of the eco-friendly choice because they avoid any greenhouse gases, and you'll often see them in environmentally sensitive projects.
So for a grid planner, the decision often boils down to this really simple trade-off. Do you need the super high performance and tiny footprint of a gas-insulated unit for, say, a dense city center? Or does the lower cost and simplicity of an air-insulated unit make more sense for a suburban or rural spot?
But the story doesn't end there, not at all. This technology is always evolving.
As our entire power grid gets this massive intelligence upgrade, the humble RMU is becoming a star player in the smart grid revolution. So what exactly takes a normal RMU and makes it smart? What's the secret sauce? What's the big upgrade?
A smart RMU is really all about data and automation. It is packed with sensors that give you real-time monitoring of everything from voltage to temperature. It's got advanced automation to handle faults all by itself, but the most critical part? It has communication capabilities. It can actually talk to the central control room, sending vital data back and forth. It goes from being a passive protector to an active, thinking manager of the grid.
And why does this matter so much? Well, because our grid isn't a simple one-way street anymore. We've got power flowing into the grid from things like rooftop solar panels and wind farms, and then we have huge amounts of power flowing out to charge fleets of electric vehicles. Managing this incredibly complex two-way flow of energy, it requires the kind of intelligence that only a smart RMU can provide. The ring main unit is just a perfect example of a piece of invisible technology that makes our modern lives possible. So the next time your power stays on during a crazy storm, you might just have one of these unsung heroes to thank. And it really makes you wonder, doesn't it, as we electrify everything at this record pace, what other invisible technologies are out there, quietly becoming absolutely essential to the way we live?